Today we're going to look at lesson 7.7, which is about exponential growth and decay. So we are going to write and solve exponential growth and decay problems. So that means that we're going to be looking at three different formulas. One of them is this exponential growth formula, and it is A equals P times the quantity 1 plus R raised to the power of T. So when we're talking about growth, we are talking about a couple of key words that are going to help it. Well, growing means that you're getting bigger. So sometimes you might see in a word problem the word increase, obviously the word grow. Sometimes you might see the word gain. Anytime you see phrases like this, we know that we're getting bigger. So we want to use this exponential growth formula. There are all these different variables. Let me tell you what these variables are representing. So P stands for the initial amount. So maybe we're starting with a certain amount of money or a certain amount of objects. That's what our initial amount is. We represent that with the letter P. R stands for rate. So what happens is they're going to give you a percentage of something. But what happens is we need this rate needs to be a decimal. But every time they're going to give it to you as a percent. So that's a problem. So if we need to turn a percentage into a decimal, there's two different ways that for us to think about that. We can take the decimal and we can divide by 100 because then that's going to turn it into the decimal that we want. Or we can move the decimal 2 places to the left. All right, so 2 different ways of getting a rate as a decimal, not a percent. So we're either going to divide by 100 because thinking about there's 100%, or we can move the decimal. T is going to represent the amount of time. All right, so let's take a look at an example here and use this information. So it says the value of a $100,000 house is expected to increase 1% each year over the next 15 years. We're going to write a model for the expected value of the house during the 15 years. So notice that in this word problem, they're giving you that vocabulary word increase, which, like I said, growth means that we are increasing, we're getting bigger. So that's why we want to use this model right here. So when they're asking for us to write a model, well, we're going to have to identify the initial amount and the rate in order to help us with that. Okay, T representing time, that's what we would need if we were actually trying to solve the problem. Okay, right now it just says write a model. So notice how we are starting with $100,000. That's going to be my initial amount. It's saying that it increases 1% each year. So while they're giving it to us as a percent, remember, I want to turn that into a decimal. So either take 1 and divide it by 100 in your calculator, or technically we've got 1 and then there's a decimal after it. We're going to move 2 places to move the decimal over here, and we'll put a 0 in the spot. So technically it's going to be 0.01 as my decimal. So my model, we want A equals, we'll put our initial amount, which is this 10,000, and then we'll have to do in parentheses 1 plus, then we want our rate, which is 0.01, and we want to keep it to the power of T. So I'm going to go ahead and actually add what I have in the parentheses. I can very easily do that. So A is going to equal this 100,000. In parentheses, then, if I add 1 and 0.01, I get 1.01, and that's raised still to the power of T. This is my model. So even though it's talking about then finding the value of the house during the 15 years, well, now if I wanted to, I could actually solve it because that's my model. t, they want to know after 15 years. So then I could actually solve by plugging 15 in for t. So if I was to solve that, I'd have 100,000. And then in parentheses, I'd have the 1.01 raised to the power of 15. So let me show you then how you would do this in your calculator. I'm sure we're all okay with that. But just so you guys are aware, that's not what I wanted. Well, I do have to do this, don't I? In our Schoology page, remember there's a calculator right here. So when I clicked on that, it takes me to decimals. So I'm going to start typing in. So I've got 100 and then 1,000. And then there are parentheses over here on the left. So I want parentheses. I want 1.01. I have to then go back and close the parenthesis. Now, the exponent is going to be this button that says a to the power of b. So I'm going to click that. Now I have an exponent and I want to type in 15 years. And then it spits it out right here for us on the right. Now notice that we have a longer decimal because we're talking money. We want to have 2 decimal places. So I can't just look though at the 8 and the 9. I have to look at the third decimal. That decimal, that's the third decimal, is going to tell me if I keep the first 2 decimals or if I have to round it up. Because it's a 5, we are going to round it up. So what's one more up than 89? Well, it would be 90. So it's going to be $116,096.90. So let me go back to our screen here. Okay, so this, when we plugged it into our calculator, was $116,096.90. So just a quick reminder on rounding. Okay, so let me write that off to the side here. So our reminder for rounding. We want to look at the third decimal. And then if it's the number 0 through 4, we are going to then keep the second number the same. And by second number, I mean the second number, the second decimal. But like the example that we just did, if there's a 5 through 9, then we are going to round the second number up. And because our second number was a 9, that would have to round it then to a 10, which is why essentially then I had to bump it up from 89 to 90. Okay, but there's our quick reminder on how we have to round. You look at the third decimal. If you have 0 through 4, we keep the second number the same. If we have a 5 through 9 in that third spot, then we have to round the second number up. All right, let's take a look at this next example. It says a company with 60 employees expects a 6% yearly increase in the number of employees. We're going to write an exponential growth model to represent the number of employees, and then we're going to find the number of employees after 5 years. So if we look at the key vocab word again, we see that we are increasing, which is why we want to have this exponential growth model. So first thing we have to do is we have to write a model. So that means that we need our initial amount and our rate in order to do that. Well, it says you're starting with 60 employees and you have a 6% increase, which I then have to change this into a decimal. So once again, either divide 6 by 100 or move it 2 decimal places. So we should get 0.06. So my model, if I have those 2 numbers, would be A equals 60, and then in parentheses, 1 plus 0.06 raised to the power of t. I'm going to go ahead and add the numbers in the parentheses together, and that's going to give me 1.06. So here is my model. And now that I have this, now I can find what it's asking. It says find the number of employees after 5 years. So now I know t equals 5. I'm going to substitute that in. So A equals 60 times 1.06 raised to the 5th power. Okay, so once again, I'll go back to the calculator. We need to make sure that we can type this in no problem. So where's my calculator? Right here. So you can either clear all or you can hit this and it just moves you to a new problem. Okay, so once again, we had 60, and then in parentheses, I want 1.06. I'm going to close the parentheses, and then that A to the power B button, I'm going to hit that, so then I can hit 5. And notice that it gives me this number, 80.29353,466. Now, we do have to be careful. This problem, we are not talking about money. So in the last problem, we needed to then round 2 decimal places. Here, we're trying to find the number of employees. It doesn't make sense to have 0.29 of a person, okay? You either are a person or you aren't a person. There's not a decimal of a person. So because this is 80 point something, I know that I want to then just automatically round it up, okay? So I'm going to round up. And so since 80 point something, the next number would be 81. So that's going to be what I'm going to have as far as my employees. So the number of employees after 5 years, we would say we would have 81 employees. Oops, I can spell it. Okay. All right, let's move on then to our next formula. Our next formula is all about compound interest. So we've got A equals P times the quantity 1 plus R over N raised to the NT power. There are some variables that look the same. There are some new variables. So let's talk about this. P is still going to stand for the initial amount. R is still going to stand for the rate. And once again, we want to write that as a decimal. So either divide it by 100 or move it 2 places to the left. T is still representing the number of times. So all of that is still the same as the first formula. But now we have this new variable, N. This is going to be the number of times compounded per year. Okay, notice that the formula says compound interest. We are going to see the word compound in these word problems if we're using this formula. And not only are we going to see the word compound, but then we're going to see a vocab word after that fact. So let me talk about then what those mean, because that's how we're going to determine what N is. So to find the values of N, we will either be compounding annually. And if you think about annual, like an annual Christmas sale, that's going to be 1 time a year. So N would equal 1. We could have semi-annually. Well, a semi-annual sale happens 2 times a year. We could be compounding quarterly. So if you think about quarters in a dollar or quarters in a year, there are 4 of them. We could compound monthly. Well, how many months in a year? 12. Or we could be compounding daily. So how many days in a year? 365. So these are the different vocab words that you could see that would then give you the value of N. Okay, so let's look at a couple of examples. We are going to deposit $4,000 in an account that pays 5% compound interest monthly. We're going to write a model for this account. So notice how it says compound and then it says the word monthly. That's why I know I'm using this compound interest formula. So we have to identify the initial amount, the rate, our value for n for compound. And then if we're just writing a model, I don't care about what t is because we're going to have that in our actual formula. So we are starting with $4,000. That's our initial amount. If we're paying 5% interest, I have to write that as a decimal. So divide it by 100 or move it 2 decimal places to the left and you get 0.05. Then we have compound monthly. So remember, how many months in a year? Well, that would be 12. So this is all the information I need in order to write my model. So if I'm writing my model, I'm going to have A equals, we'll have 4,000. In parentheses, we'll have 1 plus, and then in the top of this fraction, I want the 0.05. In the bottom of the fraction, I want the 12, and that's going to be raised to the 12 times t. All right. I am not going to simplify the numbers in the parentheses any further. I can leave it like this. This is my model. So then if I asked you for any amount of time, if I wanted to know after 2 years or 10 years or 25 years, I would just plug that value in for t and we'd be able to find our money. Okay. If we take a look at this example, it says you deposit $450 in an account that pays 2% interest compounded yearly. What will the amount balance be after 10 years? So we're compounding, and that's why we're using the compound formula, and we're doing it yearly. So that's the same thing as like annually, okay? So we'll talk about what that's going to represent in a second. So we need the P, we need the R, we need the N, and this time since we're solving, we also need the T. So we're talking about $450. That's my initial amount. We've got 2%. As a decimal, we are going to divide by 100 or move the decimal 2 places to the left. We get 0.02. We're talking about compounding yearly. So it's happening 1 time a year. It's an annual thing. And then we're asking about 10 years. So I'm going to then plug all that information into our formula. So I want 450 to go first. In parentheses, I want 1 plus. On the top of my fraction, I want 0.02. On the bottom, I want the n value, which is 1. That's going to be raised to the 1 because that's n times our t, which is 10. All right, so I'm going to go to the calculator and show you how we would type this in. Once again, you can clear all, or I can just hit this enter button and now I can move on. So we're starting with $450. So I'm going to type that. I'll go over and do my parenthesis. I want 1 plus. But now on the far right, if you notice, there's an A divided by B button. So I'm going to click that. I want my decimal on the top. So 0.02. I'm going to click this so I can be in the denominator. I want a 1. I have to click outside of the fraction, or I guess arrow over, and you're going to close that parenthesis. Then I'm going to raise it. And so now here, I think we have to actually multiply. So because it was 1 times 10, we can easily do that. 1 times 10 is 10. And notice that I've got my answer over here on the right. We are talking money, so I do want to round. If I look at my third decimal, I see a 7. So because that is in between 5 and 9, I know I want to round that second number up. So the second number is 4. I'm going to round it up. So if I go back, I know that I will then have, after 10 years, I'm going to have $548 and we would have 55 cents. So that's compounding with all the vocab words. So monthly would be 12, yearly or annually is 1, quarterly is 4, all that kind of stuff. Let's go ahead and look at the last model. We're talking exponential decay. That's A equals P times the quantity 1 minus R raised to the power of T. So same variables. We got P as the initial amount. R is our rate, which once again needs to be as a decimal. And then T is representing time. Now, the word decay means that we are losing value. So if I see this, I'm going to use that when I see the words decrease, depreciate. Obviously, if I see the word decay, okay, so those types of words indicate a loss. And so that's why we should be ending up with something smaller. Okay, so here's our first example. You bought a car for $16,000. You expect the car to lose value or depreciate at a rate of 12% per year. We're going to write an exponential model that represents this situation. So to write a model, we just need the initial amount and the rate. If we bought the car for $16,000, that's my initial amount. Notice how we're talking about depreciating, which is why we're using decay. It's saying 12% each year. So divide that by 100 or move it 2 decimal places. And so we're going to have 0.12. All right, so we've got everything that we need now to write our model. So our model is going to be A equals, we want 16,000. In parentheses, I want 1 minus 0.12, and that's raised to the power of t. So I am going to subtract what I have in parentheses. So our final answer for this model would be the 16,000 times we have 0.88, and that's raised to the power of t. And that's how we would determine the amount of money that the car would be worth after however many years. Okay, let's look at another example. Cars purchased for $20,000. You expect the car to depreciate at a rate of 25% per year. We're going to write an exponential model to represent the situation, and then we're going to find the value of the car after 5 years. So if we start with the model, I need the initial amount and I need the rate. So we're starting with $20,000. And it's a 25% depreciation. So as a decimal, 0.25. So my model is going to be A equals 20,000 times 1 minus 0.25 raised to the power of t. I'm going to go ahead and actually subtract what I have in parentheses. So that's going to give me 0.75 to the power of t. So here's the first half of our answer. There's our model. Now it's saying to find the value of the car after 5 years. So now I know that t equals 5. So we're going to have A equals 20,000 and then in parentheses 0.75, but it's raised to the power of 5. All right, so let's go to our calculator and let's plug this in. Okay, so I could clear everything, so clear all. I'm going to have 20,000, then parenthesis, 0.75. Close the parenthesis. I want a to the power of b, so then I can write my exponent, which is a 5. So notice that we've got our decimal here. I want to be talking about money. So I look at my decimals. Remember, I want the third decimal. So in this case, it's a 3. Because it's a 3, that means that the second number, which is 9, is going to stay the same. So I am not going to be rounding up here. So that means that our final answer, and notice that our answer should be something smaller than what we started with, and this is definitely smaller. It's $4,746.09. So just after 5 years, you lose a lot of money on that car.